Hey there! Let's talk about the real number system and quantities. So the basics of real numbers are determining if it's rational or irrational. Let's get started with rational. Here's a few examples. Let's say we have 1/2, square root of 4, and 3. What is 1/2? Well, 1/2 is pretty much the decimal 0.5 expressed as a fraction. And we know 0.5 is exactly half of 1. So we know that's rational because we can physically see and we know for a fact that 0.5 is a half. And the square root of 4 is simply 2, and we know that from our math knowledge. And that is a rational number because it can be expressed in a ratio of an integer, or let's say a number, pretty much. And 3 is also an integer, which means it is also rational. What does irrational mean? It pretty much means it's not rational. And it means that it can't be written as a simple fraction. Think of a whole number as a fraction. 2/1 is a fraction, so 2 is also a fraction, it's just written simply. So some irrational numbers would be, let's say, 1/3, square root of 8, and let's say pi. So 1/3, what is that? We know it's 0.3333 and so on. It never really ends, and because it never ends, we have to approximate it. And because it's approximated, it's not written as a simple fraction, which means it's irrational. Same thing for square root of 8. Square root of 8 is 2 square root 2, and the rest we have to approximate on that. And pi, we all know pi is 3.1415, and forever long, it never ends. So the key thing here is that irrational numbers never end, and they can't be simplified into a simple fraction. So let's move on here. So now, as you can see, I've pulled up 2 problems that we can solve, kind of taking this on a little tangent here. So now you know rational numbers between rational and irrational numbers. Here are rational exponents. So you know how that 2 to the 3rd power would be 2 times 2 times 2, which would be 2 to the 3rd, which is 8. This is the same thing, and just like combining exponents with square roots, what this is doing is we're first going to take the exponent, which is 2 to the 4th power, which would be 16. We would get 4 square root, the 4th root of 16. So if we think back, what is 2 times 2 times 2 times 2, which is what we just did? That's actually 16. So the 4th root of 16 would be 2. So we know that with a certain property, the inverse of a exponent power would be the same thing as a cube power. So for this next problem, you can probably expect that we would get the same result. These kind of cancel each other out, if you will, and we're left with just 3. Let's kind of take this and grasp it a little. Let's consider this. So we have, let's say, square root of 5. So if you really think about it, the square root of 5, we can think of the relationship as a fractional power. So 5 to the 1/2 power. Because if you think about it, in a way, because we're considering these fractions, we can also consider square roots as fractions because they are just like kind of canceling each other out. So for here we would have 3, 5 over 5. The 5 would be for the exponent, and the other 5 would be for the root. That's why they cancel out to be 3 to the 1 power. So same thing here. We have 5 to the 1 power here, and the square root here, so we can convert it as a fraction. So let's try another example. Let's say 4 to the 81st power, 81. So we can convert it as 81 to the 1/4 power, which is 3. This is important when you're considering polynomial equations and determining if it's a rational equation or not. So let's say we have 2x to the 1/2 power plus 3. Since we know that fractions are like square roots, this would actually be the square root of 2x plus 3. If you haven't learned yet, square root functions are actually this shape instead of the typical polynomial shape, which would normally be a straight line or a parabola. And because of that, this would not be a function. So it's really nice to determine that based on what you know from exponents and their properties. So let's move on to quantities. So here's our first quantities problem. And it says a fish tank has the dimensions of 50 feet, 40 feet, times 20 feet, times 30 feet. The water fills up half the tank. How many cubic yards can the tank hold? The best thing to do here is to really try to visualize this. Let's try to think of this tank. So we know what a fish tank looks like. It looks like a rectangular prism. So it kind of looks like a rectangle. Kind of like that, right? So let's label it 40, 20, and 30 for the height. So we know the water fills up half the tank. How can we find that? Well, we can find out the overall area first by multiplying 40 times 20 times 30. So overall area, which would be the volume, is 40 times 20 times 30, which is 24,000. So, now that we know, we have to be careful that we know what units this is in, which is in feet, to the third power, because it is a cube, so you multiply it by feet times feet times feet, which is feet to the third power. And now we know that it fills up half the tank. So let's see how much water there is. Half the tank, which means it's half of 24,000, which is 12,000 feet cubed. How many cubic yards can the tank hold? Well, cubic yards, thinking of how many cubic yards in water. So if we know that, we would know that in every 1 yard there are 3 feet. So for 1 yard is 3 feet. So that means we have to divide this by 3 to find out cubic yards. So cubic yards, 12,000 divided by 3 is 4,000. And don't forget the units, yards cubed. And this would be our final answer. Let's do one more problem. Here's our next problem. Mary leaves her home at 12 o'clock. She wants to get to her workplace at 2 o'clock, but she hits a severe traffic jam, causing her to move at 10 miles per hour. The traffic jam ends at 1 o'clock. How fast will she have to drive to make it in time to her workplace? So let's kind of visualize this, and the best way to do that is with kind of a little graph here. So we know she starts her car. Let's say we draw her little car, more like a box, and that's her, Mary. And she has to get to her workplace at 2 o'clock. And the traffic jam hits her, let's say, right as soon as she leaves. So until 1 o'clock, she's stuck in this traffic jam. So I'm gonna write here, traffic. So she slowed down to 10 miles per hour. And let's say traffic jam ends at 1 o'clock, so how fast will she have to drive to make it into her workplace? So this problem forgot to say how far is the distance. So let's say her workplace is 70 miles away. So she drives at 10 miles per hour, and she wants to get to her workplace, which is overall 70 miles. So in the first hour, she only drives 10 miles. But in the second hour, she has to drive 60 more miles. So in order for her to drive in time, she would have to drive, in this hour, she would have to drive at 60 miles per hour. And that makes it so then, overall, in her 2 hours, she drives 70 miles per hour for 2 hours. So the answer here is, after the traffic jam, she'd have to drive 60 miles per hour to reach her workplace. Thank you for watching, and this is the real number system and quantities provided to you by SATFreepractice.com.